Okay, so this is our week 2 review. So previous week review was mostly related to machine learning, what different types of uh, algorithms we can use, means what type of machine learning are, and all of that. So I will put the link below. So this will be the week 2 review. So mostly this is the review regarding the week this week where I made progress on this book, which was the chapter 2, and I was following this one as well, but here it was mostly the introduction to NumPy, uh, pandas and all these things. So I knew that, and means I have put the uh, notebooks in the GitHub link, so you can watch that. But yeah, that is mostly, that's nothing that, yeah, I need to tell that it was just steps on steps on steps in NumPy what you do and pandas what you do. So I will mostly go through this. So the chapter 2. So the way this chapter starts, right, it says that somehow you have been got an opportunity in a company that is machine learning house corporations. Okay, so without knowing machine learning, they have selected you. Okay, so now they have given you some responsibilities. Okay, so the way this chapter starts, it's first tell you that we need to look at the big picture. Okay, what we need to solve. So first thing is the frame problem. So boss tells you that uh, we have information regarding some districts, and if you stay in India, you have district or cities or something like that, right? So you have some information regarding those districts, how many people stay, what type of houses are there, how much income is of those people. Okay, and we need to predict that that district is good for our investment or not, means we need to invest in any property in a particular district or not. Okay, so that's the decision we need to make. So it says that first we should ask some questions to the boss. So something like, okay, what is the business objective, means why we want to, what at the end of the day, what we need, what we want. Okay, uh, how does the company expects to use and benefit from this model, the machine learning model that we are going to build, right? How the company is going to benefit from that. Okay, and currently what we are doing as part of that, and what are the issues with it. Okay, so why we want to move to a machine learning model, currently what we are doing. Okay, and post that you have to ask some questions to yourself. So let's start with this one. Okay, say I am an employee, ask, okay, what is the business objective? So my boss says that, okay, we need to predict the if a city is good for our investment or not, we should put money on that, how much that should be money, how much of money we should put in there. Okay, so how does the company expects to use and benefit from the model? So the way boss replies is that the model that I will build, right, the output that it will generate, okay, that this much amount should be invested. Okay, now that gets fed into one another model, which again takes a decision. Okay, that uh, is this really worth it, we should put it or not. So mostly my model, what it will do is it will predict the price for that particular building or a region. Okay, so say my company says, okay, this is the building, uh, how much money you should put in, so I will say some dollars. Okay, now the other model, that which will take my data, the amount that I predicted, and it will say, okay, we should invest on it. So that in this chapter we are just going to take a look uh, into that first model. Okay, so I am in charge of that first model, I need to build that model. Okay, so what does the current situation look like? So what it does that for now we have some number of experts who try to predict the price of it. Okay, but the problem with that is it's pretty inaccurate. It's 20% of the times we are really bad, we do some bad investment. So we need to check, okay, if with the help of machine learning can we do any better or not. Now, okay, this is the problem. Now the questions that we need to ask ourselves is it a supervised, unsupervised, or reinforcement? If you would have seen my first video, right, so uh, there are different type of machine learning. It's a machine learning model can be divided into different ways. So one of them is supervised, unsupervised learning. Okay, so my boss tells that it's mostly table data. So we will see what type of data it looks like. Okay, so it's mostly the supervised learning problem. So is it a classification, regression, or something else? So it will be mostly regression. Okay, we are not going to classify, we just need to predict the price that we want to invest in. Okay, should you use batch learning or online learning? So this is mostly means the data is not going to change much, right? I mean, over a span of a year, some few things might change, but this is not something which is rigorously changing. Something like the stock prices or something, because every day we need to predict, every day we'll get some amount of data. So that should be an online learning, but this is not something related to the online learning, so we will stick to batch learning. Okay, now the next question comes is the performance measurement. So actually this is a bit technical. So we have two ways for performance metrics. So what by performance we mean is the predictions that my model is making. Okay, that is good or not, means we need to classify it. We just cannot predict something and say okay, this is what it is. We need to say okay, this prediction that I am doing is correct or not, or how much good, means in terms of percentage or something, or in some metric value we need somewhere to measure that. Okay, how good my model is. Okay, so that's where two of them come. So one is the root mean square and one is the mean absolute error. So mostly these are two mathematical terms. So this is what I am going to predict, this is what the actual is. So what we will do is usually we have the data, we separate it into two parts. One where we like train the model. Okay, something you can say as an example. So first we prepare for the exam. Okay, that is our training, the where we can see the questions, we can see the answers as well, how we are learning, we are trying to learn. Okay, in case of test, okay, means we don't know the answer, we just need, we have the question, so we give the answers to the question, then we check with the actual answers and how we have given. So something like that. So here is mostly what we have predicted, what is the actual answer for that, so how much is the error. So this is just a parameter which tells us our model how is it. Okay, so this depends on actually how many outliers are there, means how much of wayward data is there. Something like price of a book should be, say, some, we have the data related to the books, we have some $10, $20, $30 this sort of book, and we have a book that is like 3 crores or 10 crores. That is the outlier, right? That is something wrong with the data. You don't expect such costly books to be there. So when this root mean square is much more sensitive to those outliers. So in case when we have more of the outliers, we don't predict, we don't use the root mean square error, whereas we use mean absolute error. So this is all based on the data. First we need to see the data, we need to plot it, and then we see okay how we are getting the data. Now the next part comes is getting the data. So we use our pandas library. They have provided one data set regarding the housing. Okay, so now let's look into the data. So this is how the data looks. So for every property, right, we have something like a longitude, magnitude, and housing median. It's, so as I told you, right, we are looking into a society, particular small society. Okay, so basically how much old is that society, we can say. It's basically everything we take, number of rooms, total number of bedrooms are there, how many people are staying in there, how many households are there. Okay, what is the median income. So usually it's the income. Now we are taking the median because there are so many people, right? So we are taking the median. Now the value of the houses there, what is the mean value of the houses. Okay, and ocean proximity, we'll see what is that. So basically how much we are close to that shore. Okay, so these are the columns. Now one way to look into the data is df.info. Okay, so what this tells us is first we have 20,640 entries. Okay, so these many number of rows are there, out of which you can see all are not learned, and here you will see 20,433 not learned, means apart from this others are also. What means is for some of the columns, right, total bedrooms. Yeah, so total bedrooms, here we can see number, but for some of the columns it is blank. So we need to decide what we need to do with that. Okay, so that is mostly comes in the cleaning of data part. Now okay, so the ocean proximity that I was saying, right, so see there are different types of categories in there. So mostly near the ocean, near the bay, islands. So these are the categories. So 9,000 or almost less than 1 inch ocean, I don't know what does that mean, just this is a categorical data. Okay, so we have for this column we have these many data only. Yeah, now one important way of looking into the data, right, or just getting the hands dirty, what we say. So that is like this describes. So this for every column, right? It gives us the mean, the standard deviation, what is the minimum value there, the maximum value there. 25% of the value are less than this, 50% of the value are less than this, 75% of the value are less than this, so something like that. Okay, so for all the columns, for all the numerical columns, okay, it will give that. Now we'll plot and see, okay, how the data looks like. So these are some of the steps I think we can, when we get the data right, we can perform this data. So we'll plot the data and everything. Okay, so this is how it looks like. So in that book, right, some of the observation that were made was that the median income is scaled and capped. What I mean by that is, if you say the median income, right, see the minimum value, so this stands for the minimum, okay, and this stands for the maximum value for that. So maximum is 15 and minimum is 0.499. So you can't expect at $15 income is pretty less. So what we did, right, we went to our boss and asked, okay, this seems pretty weird, only $15 is the maximum, how can it be? So the team that prepared this data, right, they told that they have scaled it, means it was like 20, 30 lakhs or 40 lakhs. So what they have done, using some algorithm, they have pushed it, means they have minimized that range. This is mostly important when we feed these data to the machine learning models, because if we give such huge data, right, 2 lakhs, 3 lakhs crores, uh, our model doesn't perform that better. So we usually try to scale that data. Okay, so we'll see later how we can scale it and what all we can do. The housing median age and the median house values are also capped. Okay, and yeah, so one thing was that median house value, that is the actual thing that we want to predict. Okay, so the this house value. Okay, so whenever say the boss comes and say, see, this is the region, this is the longitude, latitude, this is the total number of rooms and bedrooms, what do you think will be the house value? Okay, my model will predict something, then we'll decide, okay, we should invest in that or not, so something like that. Okay, that is what the actual problem is. uh, yeah, different features have different scales. So if you see, this has been scaled but this has not been scaled. Now for our machine learning model, it will see 6,000 and then it will say 15. Okay, there is a whole lot of difference. It won't understand that, okay, this has been scaled. So either we need to come up with a mechanism where we scale all the things to a basic mechanism, so that, okay, machine learning understands, so we should scale this also with respect to that, so that if it is 15 for it, it will be 10. So those are things we'll see later. And one more is the tail heavy. Okay, so basically machine learning models, right, they behave pretty good if it is a bell-shaped curve. So it is like this. So if it is bell-shaped curve, right, I'll show you how that looks like. So see, this, if this is this beautiful shaped curve, right, most of the algorithms perform well, or they expect the data to be in that. That's when they do better prediction. But here, if you see, right, it goes like so, then it comes down slowly. So this, so most of these part, right, are okay, are like that, but this side doesn't look like that. It's, this is very steep. Okay, so that's what it means. This is known as usually the tail, and this is the head part. So head part is steep, but the tail part is more. So somehow we need to fix that and make changes so that it looks more or less like this. Okay, now comes the test set. So as I told you, we can take that example when we, as a student, when he is in any standard. Okay, so some amount of books he has been given, so that he can train him, he can learn. There are some exercises in the back of that. He answers those questions. If it is wrong, he can see the answer and correct himself. He can prepare himself, so that at the end there is test set. Okay, so he goes and gives a test, whereas for test set he only has the questions but he doesn't have the answers. Okay, so that is how here also. So our models, right, first we'll give him a training set. It has to train. We won't show him the test set, because if we keep on showing him the test set, he might memorize all the questions, right? So at the end of the day, if we have given the test set also, He will go through everything and say he has memorized. Don't think he has learned it also. He has memorized it. He will be able to score good marks in the test set. Okay. If he has worked hard and tried to understood the question also, we can't say that, okay, because he has seen everything. So we need to divide the data into training set and test set. Okay. So there are certain ways. So we need to specify, okay, how many percentage. Say we have 100 columns, so we will say usually what is preferred is 20% is the test set and 80% is the training. So that's what we do. So we take all the 100 columns. Say we have 100 columns, so we randomly pick 20 columns out of it as the test set and 80 as the training set. Okay. But actually there is a problem with that. So say every time I give this iPad notebook to someone, he tries to run it again. Okay. So my model will randomly again see some test sets, some training set. Okay. Next time my model, then we again run this part of the code. Some randomly again some data is generated in the training set, some in the test set, and we give the data to the model. So now what happening with the model? If we are saying we are giving randomly, right? But it can so happen that it might see the full data set only. So in the say take one, it sees 80 train, 20 test. Okay. Later we again it's 80 train, but it can happen some of the data in the test set were in the training set, and some of the data in the training set move to test set, because it's random, right? We are randomly selecting. So every time whenever we try to select random values, it can happen that some of the training data is going into testing data, some of the testing data is coming into the training data. As a result, what can happen that in the end of the day, it might have seen all the data and would have memorized it. So that's not good, right? At the end of the day, if we give it some new data, okay, the model, it has to predict good. That's what the intention is. Okay. So that's how we test it. So there are two ways of solving this problem. So one we say is, okay, these two data we keep it in a database or something. Okay. Every time when we want to fetch the data, we pick those data so that every time it's the same. We are not changing the training set and the testing set. Or something else we can do is there is np.random.seed. If we fix this, every time that 80 training set, that 80 rows that we get right, that is fixed, we will get always those. So that also we can do. But then there is one counter problem with this also. Now what happens, say we add some more data. Okay, with those 100 we add 20 more. Now that problem happens again. 120 out of 120 we randomly select. Now again that problem might come that, okay, some of the testing we select in the training or something like that. So one way is to calculate the CRC32. So you take it this way. Say we have 10 values. Okay, we need to divide it among test and train. So 20% is the test and 80% is this training. Okay, so we have for every number, okay, 0 1 2, we generate some 32 bits of number for any number. For anything you give that CRC32, say it's a function, you give it anything, it will spit out a 32 bit number. Okay. So now what happens, say this 10 we want to segregate. So what we do is for every number we select that this 2 to the power 32 is the maximum number of values that we can get. So that's 20% of values and 80% of values. Okay, this is this one. For this 0 we calculate the CRC32. It falls in this category. 1 it falls in this category. For 2 it falls in this. For 5 it falls. For the others it falls in this category. Okay. Next time, say we make it a 40%. Okay. So what happens, that 0 value, right, which we can say was falling here. Now because we have increased the size to here, now again 0 is falling also here, but the others are falling here as well. Now when we increase the data, say we from 10 we do 11, right? 0 1 this will fall in this category. 11 can fall in here or fall in there. Okay, so this is one way of dividing the data. So you can check that thing out here. And why this is working is because yes, it is a uniformly distributed data. So you will rest assured that if you generate 10 numbers set and you want to select 50% as training, 50% as test, so it will so happen that 5 numbers of this will fall in. If this is 50% category, 50 will fall here, 50 will fall here. That's how the numbers are getting generated. So that's how it works. Okay. And the constraint that it comes with it is whenever we add some new data, right, For every row we actually select a number, we give it an identifier or id or something. It can be the numbering 0 1 2 3 for all the rows. Okay, it can be anything, so we need to select that, and that should not change. And scikit-learn also gives us, means we don't need to write our own functions. Scikit-learn also gives us a test train split, something like this, which helps us. We need to specify 20% is the test set and random stick that I told you. Okay, so it uses this method of segregating those where it went. Yeah, this way. So okay, yeah, that was it. And yeah, post that there was this important concept where it tells that, say, this media income, right? Now what is happening is, think of a child is learning tables from 1 to 5. So we are always teaching him that table for 2 table 2 ones, we are asking 2 2 2 into 3 2 into 8, some of them we are asking, so it knows. Okay, but in the exam it comes once 1 into 2 or 5 into 2, what it has learned only 2 3 4 table, and some of the data it has seen, it has not seen the 1 and the 5 table, so it will say, okay, I don't know it. But that's not how it is, right? So what we do is, when we are training it, that one table 1 into 2 into 3, we show some of the data, 1 into 2 1 into 3 1 into 5, we show him, so that in the exam when it comes 1 into 8, he is able to answer. So that's what happening here also. So say the medium income, so we are segregating among 3. So this is, you can think of poor people, not so poor, middle class, higher middle class, and rich people. Okay, these 5 segregations are there. So what is happening is, when we divide our data, we are not making sure, okay, that in our training set also all of this should be there. Say we are selecting 80%, now 80% comes as if we select only this much of data, this all goes in the test. Now it's a problem, right? Data doesn't know that there are rich or under-rich people also. When we say predict for this, it was a, I don't know what it is that. So what we do is, our both training and test set train, we divide it so that this distribution remains there. So there also, we in the training set also we have some percentage of all these 5. In the test set also we have percentage of all these 5. Okay, so this is our stratification. Okay, so there were 3 methods. One was randomly selecting, one was that CRC 32-bit generating, and the third is um, the stratifying. Okay, that's how we can divide it. Now, how to visualize some of the data? So as I told you, right, there was longitude and latitude. When we plotted this data, right, it will look some country, I think in USA. I also don't know, but that's how it was saying. And so the higher population is around, see, the Bay areas. So obviously people want to stay near about these areas, and we have much more data in those regions. Okay. Now the last thing that we learned was the correlations. This is one important thing. So one thing that I didn't understand was, how come he all of a sudden picked the median income? Why he decided that this median income distribution should remain similar in train set and test set? Why not the other columns? So the thing was that correlation usually means that 68% of it. So with respect to median house value. So this means that if there is a slight change in median income, the median house value also changes. So it's very dependent, means they are interrelated to each other. Whereas if the value is very near about to 0, right? So total bedroom, if it is changing, so this doesn't affect the median house value. And when there is a whole lot of negative, it means if the median house value goes up, right, the latitude goes down. So more we move, so latitude I think means this one. So the more we move to the south, the house of the price increases, something like that. Okay. So wait, we will see that. So see here. Okay. So see here. So we have plotted all things. So median income and the median house price. So it doesn't look like a straight line. It's going up. More of the trend is like that. Okay. Whereas for the other column, see here also you can see, but the same median house value and median income. But for the others, we don't see any such patterns. Okay, so we don't know if there is some correlation or not. But that's why we try to maintain the distribution in the training set and test set, because that is very important. Our median house value depends a lot on that. Okay, so later we yeah, try to plot it and see, okay, we are seeing some sort of lines here, see if you can see. So in the book it says that it should go up, it should not happen that at a particular value we should see so many values, so we should remove it, and also we'll see that later. Now, after that we came to the attribute combination. So where can we mix two of the columns, because the more the columns it is, uh, firstly it will take much more time for the algorithm, because each feature has its own importance, it takes much more time. And secondly, if we combine those, right, and then we try to see, okay, how is the correlation, we might get something better. So it might happen for latitude and longitude we are getting 0.04, 0.14, but when we combine these two, okay, columns and make it one column, say like a location, it might give much more correlation, minus 0.89 something, too strong. So at the end, means we have so many things to do, and this book says that start with something, do some of the data cleaning, some of the visualization, and try to get the model as soon as possible, so that, okay, we see, okay, this is how my model is preparing, say it's 68%, it comes out of 100 predictions, 68% it did good. Now then go back and see, okay, what else we can change. Something like this attribute combination, we try to combine then different columns and see, okay, how my model is behaving. So this is sort of an iterative process where uh, we get up a prototype, get it up and running, we see how it is behaving, then we go back and what else we can change so that it keeps on improving, or if it is degrading, so based on that we makes the decision. So this was mostly the week 2. So it was actually good. You can go through this book, sorry, not this one, yeah, this book, it's good, pretty good actually. At least I have an understanding of what I need to do. Previously when I started, right, so it was too much on me, because when I used to see, okay, I can do this correlation, that correlation, there are so many combination that is possible, among them 3 of them also we can combine, so which one to pick up, which one not to pick up. So at least one thing that was very good was this thing. So it does that once you get a prototype up and running, you can analyze its output and gain more insight and come back to exploration steps. So mostly get up with the model as soon as possible, and then, okay, how it is behaving, then what else we need to change and what else we can do, and that's all things comes in there. And mostly this also I was going on, so in 1 week 3 days, I, you can say, I go through this one, 3 days I go for this one. And this was mostly related to introduction to pandas and numpy, so which was like nothing to share it, so I have kept it in my ipython notebook, you can see there. So okay, thank God, that was it. So at least 2 weeks I have tried to maintain the progress, and I think I have learned something at least, what is machine learning and how, when we see the data, how to get started with it. And so it feels good. Actually, one more thing, the maths, I am also looking how to get into that math, because Daniel Borger, right, who was here, he told that maths and Python also we need to brush up, so that we understand actually what is happening under the hood. Mostly here, right, we are using predefined function. Till now, there mostly we have written, but something like these. Okay, so in the book it was written that it won't be from the scratch. Already some functions are written, and we are trying to use it. But at the end of the day, the more of the fun when you know, okay, what is happening under the hood, can we modify something there or not. So that we need to learn maths. So I'm looking for what are different resources that can help me in learning maths. Do let me know if you know. Mostly the top bottom approach means first they show the application and then they show the theory, because mostly where I am going, right, first it's a whole lot of theory, then we get to know, okay, something like linear algebra, probability, calculus. So that's what I found very difficult. So mostly I want that pragmatic sort of a thing, means okay, I know the application, what, where I'm going to use the linear algebra, how it is done, so those sort of thing. So okay, I will let you know in week 3 if I get any maths, tutorial or book or something like that which can be helpful. Okay, so okay, bye bye.